Today's lesson is going to be over Pythagorean Theorem. Pythagorean Theorem, the formula that goes along with this is a squared plus b squared equals c squared. And how you know what a, b, and c is, you find where your right triangle is, and this only works with right triangles. Alright, so once you locate where your right triangle is at, across from your right triangle is always your C, which is also your hypotenuse. Which, remember, the hypotenuse is always the longest side of a triangle. Okay, so this is our hypotenuse. Alright, so now let's look at the other two, A and B. Well, the two sides that create your right angle, so here's your right angle, so here's one, and here's one. So here's your two sides that create your right angle. These are called your legs. These are your legs of a triangle. So and these are, you can go either way. One leg is going to be your A side, and the other leg is going to be your B side. So, to clean it up a little bit, here's my right triangle, or my right angle. So to create my right triangle is here. So there's A. Create my right triangle here. So there's B. And the longest side, which is always opposite your right angle, is your C. Okay. So when you're finding the hypotenuse, you're going to leave it set up in the traditional A squared plus B squared equals C squared way, because you're trying to find your C squared. But if you're trying to find a leg, we're going to switch it around a little bit, and we're going to go ahead and put C squared over here. We're going to subtract one of the legs to get our other leg measurement. Okay, so then you have hypotenuse minus, oops, I can't spell, hypotenuse minus a leg is going to give you a leg. Okay? Alright, so let's do a few examples of these together. Okay, so let's say we're given this side as 1 and this side is 3, which means this is my right triangle, so this is a leg, this is a leg, so we're trying to find our hypotenuse, which is C. Okay, so if we're trying to find C, we're going to leave it in the traditional way, and we're going to substitute in. So one leg is 3. And sometimes, in the past, students, it makes it easier to say A equals and B equals, so you can see exactly where that's going. So I have 3 squared plus my B is going to be 1 squared equals C squared. So let's simplify some of this. So 3 squared, remember that same thing as 3 times 3 is 9. Bring down our plus sign. 1 times 1, or 1 squared, is 1 equals C squared. 9 plus 1 is 10 equals C squared. Now the opposite of squaring a number is to square root. So you know how inverse operations, adding, subtracting, multiplying and dividing. Okay, squaring a number and square rooting a number are your inverse operations. Alright, so we're going to square root this, which cancels out our squared, so we're just left with C. Square root 10. If it wants the exact answer, square root 10 is your answer. If it's asking you to round, like some of the work that you do on Delta Math, it asks you to round to the nearest tenth, so you would type this in your calculator, and you would get 3.2 is approximately C. So this side is 3.2. Now you can always check it. It's not by much. But this is 3, this is 1, 3.2, this is always your longest side. So if you get something smaller than one of your legs, you know you done some of your math incorrect. Okay, if you'll pause the video, and I'm going to write some dimensions first, hold on. And you might try this one on your own first. Let's say this side is 5, and this side is 12. So here's our right angle, so we're going to be looking for C. Pause the video for a second, try this on your own, and then come back and check. Okay, I'm going to go ahead and erase this just because I don't have enough room. I'm going to try to write smaller on this one so I can leave it up. All right, again, we're trying to find our C. So a traditional way, a squared plus b squared equals c squared. Okay, here's my leg, so I'm going to say A. Here's my other leg, so I'm going to call that B. So I substitute in 5 squared plus 12 squared equals c squared. Okay, let's simplify this out. 5 times 5. 12 times 12. Bring down our c squared. Let's do some simple arithmetic. 25 plus 144. It's going to give us 169 equals c squared. Again, inverse operation. So I'm going to take the square root of both sides. That cancels our squared. So I get c. If you type this in the calculator, this is going to, like I said earlier, the square root 10 up here was the exact answer, but this is a perfect square, so you're going to want to simplify. Type in your calculator square root 169, and you're going to come up with 13. Okay, now let's do one that's a little bit different. Change colors. Let's say that this side is 5, and this side is 9. Now let's see how I switch this up a little bit. Here's my right angle. So now we're given C. We know our longest side. This is a leg, so this is A. And this is a leg, so we can say this is B. Now remember, we can switch these around. Okay, it doesn't have to be A and B. So earlier I said C squared minus A squared gives us B squared. So again, if you label this as B and you want to switch this around, you could say C squared minus B squared equals A squared. Okay, you can switch these two around. So let's look at what we have here. And since we're trying to find A, we want A isolated on the equal sign. Okay, this is what we're finding. Okay, so let's fill in here. I know that C is 9. So I have 9 squared. We're going to subtract this time because we're taking away. And then I know that B is 5. And that's going to give us my other leg. So let's simplify a little bit here. 9 squared, so 9 times 9, 81. Subtract 5 times 5 equals A squared. Okay, let's do some simple subtraction here. 81 minus 25 will give me 56 equals A squared. Okay, again, inverse operation. So square root, whatever we do to one side, we have to do to both sides. So this cancels. So A is, again, this is not a perfect square, so this could be your exact answer. Or let's type that in the calculator, because I want you guys to round to the nearest tenth. I can't spell. Round to the nearest tenth. So then we're going to get, and actually we're going to do approximate. Remember, this means approximate. It's not an exact answer of 7.5. Okay. So again, if we're looking for a leg, we're going to subtract. If we're looking for the hypotenuse, we're going to add. And just let's do some really quick, very simple. This really came out to be, remember, 7.48. Remember, to round, you look at the number, we want the nearest tenth, so you look at the number right behind it. If it's 5 or larger, you round up. So that's why we have the 5 here. So when you're entering into your work, make sure you are rounding correct. Don't let the very last step, simple step, throw you. Okay, let's do another one where we're trying to find the leg of a triangle. So this one, let's say our hypotenuse is 74, because that's going to be opposite our right angle, so that's going to be our C, and our leg is 24. So let's say this is A, and so we're looking for B now. All right, so now we are trying to find B. So that means we want that one isolated on the equal sign. So we have c squared minus a squared equals b squared. Okay, c is 74 squared. A is 24, so we're going to square that one, is equal to b squared. 74 squared is 5,476 minus 24 squared. Oops, I don't know what happened there. That's subtraction. All right, 24 squared is 576 equals b squared. Okay, let's subtract these two, and we're going to get 4,900 equals b squared. Inverse operation of squared, so cancels. Inverse operation. So when we take the square root of 4,900, hopefully you see that that's a perfect square. Square root of 49 is 7, but we want 4,900, so that's going to be 70 equals b. Again, do a quick check. I have 70 and 24 as my side, so hopefully my hypotenuse is the longest side, which it is. Okay, hopefully that helped you with Pythagorean theorem.